Welcome to this comprehensive guide on namespaces and assemblies in Unity, tailored specifically for beginners. Understanding these concepts is crucial for writing cleaner, more organized, and maintainable code in your Unity projects. Namespaces are fundamental to scripting in Unity and C Sharp, acting as containers or folders to group related code elements like classes, interfaces, and structs. Their primary purpose is to organize code and prevent naming conflicts that can arise when two different sets of code have classes with identical names. Think of namespaces as family names. You might have multiple Johns, but John Smith and John Doe are distinct. Without namespaces, you'd always risk naming conflicts, especially when using multiple libraries or assets in a project. For instance, both Unity Engine and system namespaces contain a random class. Namespaces let you specify which random class you intend to use, avoiding ambiguity. Namespaces help organize your code into logical groups based on functionality or domain. For example, you could group all UI-related scripts in a UI namespace and physics-related scripts in a physics namespace. To use a namespace in a script, you can use the using directive at the top of your script. For example, using Unity Engine allows you to use Unity's built-in classes without needing to write Unity Engine that game object every time. You can create your own namespaces by wrapping your code in a namespace. Now, my class is part of the MyGame namespace. To use it in another script, you either include using MyGame at the top or refer to it as mygame.myclass. Namespaces can be nested to create a hierarchy, further organizing your code. For example, namespace mygame.ui creates a subnamespace within mygame. If you don't explicitly assign a namespace, your class is placed in the global namespace. An assembly is a compiled C# code library containing classes, structs, and references to other assemblies. In essence, it's a package of code that Unity can use. By default, Unity compiles almost all your game scripts into a predefined assembly called assembly.c#.dll. While convenient for small projects, this can lead to longer compilation times as your project grows. To organize your code into smaller, more manageable units, you can create your own assembly definitions. This involves creating an assembly definition asset in a folder containing the scripts you want to include in that assembly. One of the key benefits of assemblies is reduced compilation time. When you change a script in one assembly, Unity only needs to recompile the scripts within that assembly and any dependent assemblies. This can significantly reduce compilation times, especially in large projects. Assemblies also promote improved code organization, modularity, and encapsulation, making it easier to manage dependencies and refactor code. Furthermore, assemblies allow you to compile code for specific platforms. For example, you can create an assembly that only includes code relevant to Android or iOS. Assembly definition references are useful when code that should belong to the same assembly is located in different folders. It acts as a pointer to an existing assembly. To identify which assembly a script belongs to, select the script in the Unity project window and view its properties in the inspector window. Assemblies allow you to think clearly about the architecture of your code, helping manage dependencies and reducing unnecessary recompilation time. They also make your code easier to debug. Assemblies help enforce encapsulation and modularity in your code. Code in a given assembly can only access the types and functions in that assembly and any assemblies it explicitly depends on. Now, let's cover some practical tips and considerations for effectively using namespaces and assemblies. First, start early. Begin using namespaces and assemblies early in your project to establish a good code organization foundation. Next, focus on logical grouping. Group code into namespaces and assemblies based on logical relationships, such as features, modules, or systems. Avoid over-engineering. While assemblies offer benefits, avoid creating too many small assemblies, as managing dependencies can become complex. Configure your code editor, like Visual Studio or Writer, to recognize your project's root namespace. This ensures that new scripts are automatically placed in the correct namespace. When creating assembly definition assets, the assembly name and its dependencies can be configured in the inspector. By understanding and utilizing namespaces and assemblies effectively, beginners can write cleaner, more organized, and more maintainable code. This leads to faster development times and more robust projects. Thank you for watching this guide. We hope this helps you build better Unity projects.